Welcome to IASG. Today we have a couple things going on. We're going to do a talk on password cracking by Kole, and then afterwards, for kind of the after event, my group from COMET 309 last semester, we're going to be presenting the malware that we developed for the class, and just kind of go over that and talk about how we made that. So yeah, we'll just give it over to Kole.
All right. So before I start this talk, I'll just go over last week's puzzle real quick. It was an encoded string that had 3 different methods of encoding not applied to it. The first one was this little chunk right here, which is base 64. It's all the uppercase and lowercase letters, all numbers, and plus and forward slash. Pulled in CyberChef, just decoded it. And this is the first third or so. So got that part. Second third was a bit more obscure. It's base 32, which is all the uppercase letters and numbers 2 through 7, which takes us through there and here. And then the last third was ASCII 85, which I'm not even too sure what the parameters are for that one. And that's not even in CyberChef as far as I know. Have to do it on a different website that decodes ASCII 85, and that gets us the last third. Questions on this one? Okay, so I'll get the password cracking real quick. So for this one, there is a demo posted if you want to follow along. It's in our Slack channel. If you haven't joined our Slack yet, now is a good time to get on that. It's intended for if you're working in a Linux environment, preferably Kali, because there's to be some, if you're not in Kali, there's some programs you might have to install. And password cracking is defined as the process of recovering passwords by making repeated guesses. So this doesn't include things like social engineering to get passwords or installing keyloggers to get passwords. And it says recovering passwords, which I think is just a way to make it sound less malicious. 2 main types of attacks are the brute force attack, where you basically just try every possible combination of characters. You'd start with, is password lowercase a? No. Okay, so lowercase b, lowercase c, yada, 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 lowercase z. Then you might move on to, is it 0, is it capital A, is it exclamation mark? And then after you tried all the 1 characters, you move up to 2 characters, starting with lowercase a, lowercase a, lowercase a, lowercase b. So it takes a long time, but it tries everything, so you will eventually get there if you have like hundreds of thousands of years to wait. But a lot of times you don't have that much time. If it's a password that's like, I think 9 characters or more, you're gonna be waiting for months. So that's why you have a second attack option called a dictionary attack, or a word list attack, where you basically just have a text file containing a list of potential passwords separated by line breaks, and it will just iterate through the dictionary until it gets to the end or until it finds the correct password. Dictionary attacks tend to be a lot quicker since you just are trying less things. They typically just contain like popular passwords that are used, or like a leaked database that had password in plain text, or if you're like attacking someone specific, you could fill a dictionary with just like details about them, like their personal life, since people like to use personal details for passwords, and then mangle them to find like common substitutions or combinations of words to find potential passwords that way. So first demo I have is zip files, password protected zip files, which aren't really what comes to mind for most people when you think about password cracking. They're kind of something a bit more obscure, and you probably don't really use them personally, but they are still pretty common. They're used in CTFs pretty often. I think both of the last 2 fall CDCs both had a password protected zip file as an anomaly. So they do exist in some form, but they're easy to crack as far as like how complicated it is to run a script against them. And the program I'm going to be using is called fcrackzip, which we got right here. So in this directory, I just have 3 zip files. This one's 9 characters long. This one, password-wise, this one's 9 characters long. This one's 5 characters long, and this one is 4 characters long. So first command I'm going to be running is fcrackzip-ca-paaa-u test.zip. Basically what this is doing is fcrackzip name of the program. -c specifies the car set if you're doing a brute force attack, and it's just lowercase a, so that means I'm just trying only lowercase letters. -p is basically like the starting password you want to do. So in this case, AAA means I'm doing every combination of 4 letter passwords. -u actually makes it test a password. If you don't do this, it will just print out a list of like 6,000 potential passwords, which I don't know why I'd ever want to do that. And then just name the file. So run it, and it will take about 3 seconds. So that's a brute force attack on a short password. The contents of the directory is something interesting, but if so, like you expand the character set just a little bit, like just from instead of just doing only lowercase letters, you do lowercase and uppercase letters, it will take considerably longer time. I think this takes about 12 seconds or so to crack. Yep. And then same situation if you do like a longer password. So like if I do one for test 5, which is a 5-character password, add an A here and go to this. I think this takes about 25 seconds or so. And if I try to do a crack with a 5-character password and both lowercase and uppercase letters, it takes too long for this presentation. So you can kind of quickly see just how brute force attacks will exponentially start to take too long to do, since as you add characters, it increases the time required to do it exponentially. This should be finishing up pretty soon. There it is. So even then, it's 5-character password. It starts with an F, so that's just like in the first quarter of passwords I would try. So if I just did something like zebra, that would increase the time to 2 minutes or something instead of just 30 seconds. So again, this takes too long, really. So that's why you have the other option to do a dictionary attack, which, so kind of for this one, -V is verbose. This one doesn't really do anything. -D means dictionary. U, again, actually do it. And then for the -P switch, this time you'll specify the dictionary you're going to be using. And this one is called rocku.txt, which is pretty common. It comes with Kali. It's about 100 megabytes in size. I'll explain more about where this comes from and why we have it later on. We'll just run this one again. This one's a 9-character password, and found instantly. So that just kind of shows you that for longer passwords, even just shorter passwords, like if I just do test 5, it's still just faster than a brute force attack if it's actually inside the dictionary. And yeah, so this is mostly just kind of an introduction because it's easy to crack zip files, just run the one command. And you might think that this is just something that's like not actually like real world applicable, but there are a few cases where this has come in handy. I know like a few years ago, I think it was a firefighter who on his computer, he was accused of having illegal content. And they searched his computer, didn't find anything, but they did find a password protected zip file, and they broke that, found illegal content, and that's what led to his arrest. All right. So second thing I'm going to be cracking are web logins. These are traditionally slower than zip files because in this case, it's not on your computer, it's somewhere else, and you have to account for things like pings and just them being slower than your computer, stuff like that. So to kind of counteract that, while you do these password crackers, this one's called Hydra. There's other popular ones like Ncrack and Medusa that basically do the same thing. They all come with Kali. They will run attacks in parallel. So basically what that means is instead of waiting for their check to come back as a failure, they will just send 16 or so at the same time and see if any of those worked. And if they don't, it'll send 16 more, and it'll keep doing that over the applied dictionary or brute force thing you're running. So I'll run Hydra against an FTP server. Let's see. Close out of this one. So this is a FTP server I have running on localhost. The command for this one is Hydra-T32. That specifies how many sessions it's going to open at the same time. For Hydra, you can do any number between 1 and 64. When I do 64, Hydra crashes, so I can't do 64. The -L switch specifies the username of who you're going to try to crack. In this case, this is a user called admin. And then the -P switch specifies the dictionary you're going to use. In this case, I have one called 500.txt, which is just a list of the 500 most common passwords. This -VV prints the output, so we can see like what it's trying against. Running against localhost and trying to crack an FTP server. So let that go, and you can see first 32 guesses are right there, and then the next 32. This is going to take a little bit, so are there any questions so far? Nope? Okay. Let's see what else. So, okay. When you're running against a website, it's easier to crack things like FTP or SSH because, as far as Hydra knows, there's a pretty clear like confirmation or non-confirmation, can't think of the word, as to whether or not the password worked. You either have a shell or you don't have a shell. When you're cracking something, and here it is. When you're cracking something like an HTTP form, it's not as clear cut. Basically what it looks for in an HTTP form is what's the error message returned when you guess the wrong password. So like invalid username or password, and it'll just keep trying passwords until it doesn't see that string returned. And so you can see they figured out that password was password123, which is about 10 up, so it didn't stop when it found the password. It still did that whole 32-piece chunk. And just to demonstrate why it's so important that we run these attacks in parallel, as opposed to just doing one, waiting for see if it works or not, and then doing the next one, if you just did one at a time, it would be very slow. There's first one, second one, third one, fourth one, not worth the time. That's why you want to run them in parallel. Okay, so before we move on to the next thing, I talked about RockU a bit, and like kind of what it is, but let's go into a bit more detail. RockU was a website that was integrated with MySpace and Facebook, which was, I guess, for gaming or something, which had about 32 million people sign up for it, and they got hacked because they had a 10-year-old bug in SQL that didn't want to patch, and they had all their end users' passwords stored in plain text. So that plain text document got leaked, and now we just have this nice list of 26 million potential passwords to crack with, which is pretty bad from RockU practice-wise. Typically when you are storing passwords on your computer or on a server, you want to store them not in plain text. Any other way would be better, two-way encryption even, but the best way would be through hashes. And if you're not familiar with the hashing algorithm, basically you have your string, you have the hashing algorithm, and then you have the output. And the output is just a string of fixed length. Like you see, all these inputs have the same length of an output, which appears to be random in the sense that if you have the output, you cannot find the input without just guessing possible passwords over and over again until you eventually get it right. So back to cracking, basically. And the good thing about a good hashing algorithm would be, even if you're like close to the input, it still wouldn't be like a close output. Like for these two inputs right here, they only differ by one character, but the outputs are completely different. And so typically when you're storing passwords on a server, you want to store them in a hashed state. But it's not just good enough to use a good hashing algorithm. Like you might know that MD5 and SHA-1 are considered bad, so you use SHA-2, but just storing passwords as SHA-2 isn't exactly enough because you can still crack those hashes multiple ways. First way I'm going to show is a program called Hashcat, which is, I'll make this bigger again. A little bit bigger. So the program called Hashcat is basically just right back to password cracking. This command, you have the -M1400 switch, which is the mode you're running Hashcat in. If you check the man pages, there's like 30 or so modes. I don't know the exact number. 1400 just stands for SHA-256. -A0 is the default attack mode, and then this local file, SHA-256.txt, I'll show what that is in a second. And then once again, we're just going to use RockU to crack it, which is the next file specified. I don't remember what --force does, but that's important. And the pot file disable switch is because Hashcat likes to store found hashes solutions in memory. And if I ran this earlier in testing, and if I run it now, it would just be instant. So kind of just doing this to show you like how long it actually takes. And there's a list of about 20 hashes in this file, which we'll just try to crack quickly. My battery's not, crap. Didn't plug in my charger. Wow. Okay. Almost made it. Let's give me a to reboot. Any questions so far? Nope. appreciate it, thanks. Okay, so where was I at? Okay, so it took a minute, 20 seconds, but really it just takes 15 seconds. It's longer because it included the time it took for my computer to turn off and on. It cracked 12 of the 20 hashes. Let's see. This is what the file looked like. It cracked about 12 of these, which I just grabbed from RockU and hashed them. These are the passwords provided. And yeah, so that was, oh wait, I have the mic on, whoops. So that took it takes about 15 seconds of practice, so that's decently fast, but if you're like trying to break through a list of like 5 million or so, something you actually got from a database, that's kind of too slow. So there is a faster alternative, if I can get this highlighted. And that's through what are called rainbow tables. And rainbow tables are basically just large files that contain pre-compiled hashes and the password used to generate them. And they are sorted by the hash, which means that if you look up a hash on a rainbow table, you can find the password that is used to create it in O of log n time, as opposed to just O of n time if you're doing like Hashcat, something like that. So that's used to speed up the process a bit. And these rainbow tables are typically like 150 gigabytes in size, so I couldn't actually download one to my tiny partition. But there is this website called Crack Station, which is basically just an online way to search through rainbow tables, I guess. They got it's about 200 gigabytes total, and just drop it in, hit crack, and that took like 4 seconds, I think. So a lot faster in that sense. And it found the same ones that Hashcat found, and also this extra one, which was not in RockU. So their tables are more content in their tables. Along with just having like different passwords, also have like all possible brute force combinations from like 0 or 1 to 8 characters or 9 characters, something like that. So pretty good size, which in turn kind of means that in that sense, the hashes aren't really doing their job if in just like a few minutes you can run rainbow tables on a database and get a good chunk of the passwords back. So there's a better way of storing hashes, and that's with what are called salts. And salts are basically just short little strings that are appended to the beginning or end of a password before it is hashed, which gives it just more, I guess, entropy randomness, which means that if someone's password is like just password, it would be password AHCDF, and that would be hashed, which is less likely to show up in a rainbow table and basically makes rainbow tables kind of useless. But just because the password is salted doesn't mean it's uncrackable. If the salt is like short, like 2 characters long, then you can still brute force it if you don't have it. And if the salt is the same for every user, then you just have to figure it out once and then you'll be good. Like say you had like a list of like 1 million hashes and you saw the same hash repeated 1,000 times and you knew it wasn't unsalted. That one hash that's repeated so often is probably like one of the 10 most popular passwords or something. So you could try to crack that hash by using a dictionary of just like 10 passwords, and then try to brute force the salt by just saying all combinations of like 2 letters to the beginning, all combinations of 2 letters to the end, combinations of 3 letters to the beginning, 3 letters to the end, something like that. And then you could get the password, the one hash, which would give you the salt, which would mean you could just go back to using Hashcat. So the preferable way is to use salts that are of decent length. I think the standard's about 10 characters or so, and also unique for every user, which is what is commonplace. If you look at like a local Linux machine, you'll see in Etsy Shadow is where the hashes are stored, that's how the hashes are stored on Linux. So real quick, I'm just gonna create 2 users with the same password. And then if we check Etsy Shadow and see the passwords for Greg, this is what the hashes are stored as in Etsy Shadow. First row is just a username, followed by a $6, which is a symbol for the hashing algorithm that's used. 6 refers to SHA-512. And then this string right here is the salt, which looks like 7 characters long, and then here is the actual hash itself. And then if you look at Greg and Greg 2, they have different salts. This one's different than the one above it, and the hash is also different. So passwords stored in the same system in a different form. But this doesn't mean that it's uncrackable still. Because in this case, if you manage to grab a hold of an Etsy shadow file, you still have the salt. So you can just crack it in that sense, just append the salt since you know it, and go back to cracking like before. Okay, hold on. So if I append this to a file called, let's go shadow.txt. So our file just has, in this case, just 2 hashes. And if we run another password cracking program on it called John, am I still sudo? Yeah. Then it will, again, just run through its dictionaries and brute force stuff. So it does a lot of things using the salt provided, using the hash provided to try to see if it can break it. And see, I don't remember how long this one takes. I don't think it's too long. Any questions right now? All right. I think this one took about 30 seconds or so to do. Okay, I had a backup file in case this didn't work. Oh, right, that's what I did wrong. -- show switch at the end actually tells you what the passwords are. So in this case, Greg's password and Greg 2's password, they were both password, and I was able to crack them in about a minute. These 2 were cached, which is why they appeared immediately. So even through all that, using the actual security measures that Linux is using, we can still crack the hashes just because end users will always continue to use shitty passwords and always be able to be cracked. Which means that in the end, password cracking mitigation, for the most part, falls on the end users. So as an end user, if you want to protect yourself against password cracking, use good passwords. You've heard it a million times. Make them like 12 characters or longer so they can't get brute forced. Check through RockU to make sure your password's not in there. Actually, I'll go just show you that how comprehensive RockU is. Yeah, so I mean, RockU consists of just like everybody who tried to just put password as their password and append a bunch of characters to it. Everybody who did like 1, 2, 3, 4, 5 or something like that alongside it. Again, thousands of these still. And even like other things like names of celebrities or something. Plenty of passwords that you can find. So it'd be a good idea to search through a word list like RockU to see if yours is in there. If it is, definitely gonna want to change it. Other things you want to do is, as a sysadmin, you're gonna always want to keep passwords hashed at the very least and salted. You want to make sure that the salt is randomly generated each time for each user, and it is decently long. If you haven't taken 309 yet, then you could apply this to your 309 database as a good short project. It actually doesn't take all too long if you know what you're doing. As far as web logins go, you want to try to time out clients after too many failed password login attempts. Just time out for like 2 minutes. That way it will slow down brute force attacks. What else? You also want to put a delay between actually like verifying the password was wrong and telling the end user that it was wrong. Also kind of slows down password attacks. That's why when I was doing the FTP server, there was such a long delay between sending the 16 attempts or sending 32 attempts and getting back the response that they failed. It's also why when you're working in a Linux environment, and if you ever like use a wrong password for sudo or for SSHing in or just logging in general, there's like a 2-second timeout before it says try again. That's all to stop brute force attempts. Any questions about anything? All right.